Hello, everyone. Welcome. My name's Kat. I'm the children's librarian here at the Tewksbury Public Library in Tewksbury, Massachusetts. Welcome to our museum series. Tonight we have our guest from the Museum of Science in Boston. This series is brought to you by the Institute of Museum and Library Services and administered by the Massachusetts Board of Library Commissioners. We got a grant from this program, so we're very grateful that we're able to bring this to you. If you have any questions, you can add them in the chat. Please keep muted because we do have a lot of us tonight, and that way we'll make sure that we're not all talking over each other. All right, Katie, it's all yours.
Great, thank you, Kat. Hi, everybody. My name is Katie. My pronouns are she and her, and I am an educator from the Museum of Science in Boston. I specifically educate in astronomy. That's my specialty, so I'm really excited to be here and to talk to you all about what's up in the sky tonight, also what's in the solar system. We'll do some traveling around, and you'll get to see some other parts of the galaxy, and we'll hopefully go even further out than that. So I'm going to be using two different space simulating softwares today. They are both free and they are both open source. So if you ever are interested in downloading them and playing around with them yourself, you can do that. One of them is called Stellarium. That's the one I will be using first. And then the second one is Worldwide Telescope. And I'll have the links for you at the end if you do want to check those out. As Kat mentioned throughout the show, I will be potentially asking some questions. See if what planet might be most popular. If that's the one you want to go visit, you can type that into the chat when I ask it. Or if you have a question about something I'm talking about or anything, if I'm not clear on something and you have a clarifying question, please feel free to put it in the chat. I will try to leave some time at the end so that we can do a more proper Q&A session. And I will try to keep my eye on the chat and pause every now and then so that I don't miss anything. All right. So with that, let's get started. So right now, everyone should see my screen, which is Stellarium. So if you haven't pinned me yet, you probably want to pin so that this window is nice and big on your computer. And hopefully everyone can see my cursor. I bumped it up a little bit in size and made it red. So hopefully that will make some things clearer. So this is what Stellarium looks like. It's a great software. You can set the time to any time you want. You can also set your location to anywhere on the Earth. You can even go to other planets and view the sky from there too. But I have this set for Boston at around 10 o'clock tonight. So just in about 3 hours.
What's it called?
This program is called Stellarium. So I'll have that written out for you at the end. And then if you wanted to look for it on your own, you can do that. Because it's also right up here at the top. I don't know if you can see that or not. All right, so go ahead and just take a look at this part of the sky. We're looking north right now. Maybe think about some objects that you might see, make some observations, see if you find anything familiar, you think about it. If you're sitting next to someone, you can point something out. I will say that there is one very bright group of stars in this part of the sky that is pretty familiar to a lot of folks, especially up here in the Northern Hemisphere. All right. Awesome. All right, so now I will go ahead and start pointing things out. So right here, if you were looking at this group of stars, very low on the horizon in the north, and I'll kind of tilt it up and zoom in a bit. This is the Big Dipper because it's shaped like a giant spoon that has a bent handle. So we've got 1, 2, 3 stars in the handle, and then 1, 2, 3, 4 in the bowl. This group of stars is not a constellation, which usually surprises people, but it is part of a constellation called Ursa Major. So the entire constellation comes out here to a point, and then it comes down here, and some of it goes below the horizon. So I can actually connect the dots for you if I click on a star. And now you can see what the whole constellation looks like. Now, this constellation is supposed to be a bear. and it's called Ursa Major, so it's the big bear. I've gotten lots of other observations, like it looks like a giant rocket ship that has legs, or a frying pan with legs, and all of those are more valid than the bear, because the bear, it's a really big stretch. You got to use your imagination to see the bear, but I can also help you out by adding some artwork there. So there is Ursa Major, the great bear. Now, the constellations that I'm talking about today are the constellations from mostly Greek and Roman mythology. There are lots of different sets of constellations from all over the world, and this program actually allows you to see some of those other sets, but these tend to be the ones that we're most familiar with. So I have these set, but if you saw something else in this part of the sky, chances are someone else in the world at some point also saw that thing. All right, so that's just one group of stars, the Big Dipper inside of Ursa Major. But what's great about the Big Dipper is that you can use it to find the Little Dipper, also known as Ursa Minor. So for this, we're going to take these two stars. These are called the pointer stars of the Big Dipper, and we're just going to stretch them out in this direction. And it's roughly, you want to go about 5 times this distance until you run into a star. So if we just go straight up in this direction, the first star that we run into is right here. This is the first, at least brightest star that we run into. And this star is a very famous star. You might already know, you could tell by its location in the sky. That is the North Star, also known as Polaris. So I can click on it there. You'll see it's got a lot of names across many cultures and many catalogs. But this star is really famous, not necessarily because it's big and bright and cool looking, because if you compare it to other stars in the area, you'll see that it's not, particularly, doesn't stick out a whole lot. But it's famous because it's always in the north. So because of Earth's axis, and because Earth spins, it actually happens to almost perfectly line up with Earth's axis of rotation. So as the Earth spins and stars look like they move across the sky, because of that spinning, it's kind of doing this motion, like it's rotating around this point in the sky. And so it just happens to line up. It's a total coincidence that we have a star that's there. So it's really useful for navigation, finding north if you're ever lost in the woods. Hopefully at this point, people will have, maybe a GPS or a compass on their phones or something like that, but at least you now know how to find the North Star. So that's the end of the Little Dipper right here and the Little Bear. And I will turn on the Little Bear because it's very cute. You'll notice these bears have very long tails. There are a lot of stories that go behind the bears and why they have long tails. One of my favorites is that Zeus, the king of the Greek gods, took the bear by its stubby little tail and then swung it around like a lasso above his head and launched it out into space. And in that whole process, the tail of the bear got stretched out. One of many, many stories behind these constellations. All right, so I'm gonna kind of move on to one other part of the sky before we head up into space. So I'm gonna turn our attention over to the east and southeastern part of the sky. And I will pause briefly to see if there are any questions. All right, so there's one, is this the same software that the Planetarium uses in Boston? It is not the same software. Unfortunately, that software can only run on the machines in the Planetarium. So this is a different open source software that's really awesome and accurate, uses real data to show the night sky and the solar system. Someone's asking about planets. And that's a great question because there are some planets that are visible. They're not in the north, but if you did see a really bright object, it might have been a planet. So I will point those out after I talk about this part of the sky. A constellation, what is a constellation? That's a great question. Thank you for asking. So a constellation is basically just a made up shape in the stars. Astronomers use constellations kind of like a map to find different objects in the sky, or if they're pointing a telescope at a certain part of the sky, they can kind of communicate what part of the sky they're actually looking at. Like, I'm trying to find a galaxy over in the constellation of Taurus or something like that. And that kind of shows that it's like a map, essentially, map to the stars. All right. Oh, it looks like, are we having audio issues? Can everybody hear me?
I can hear you just fine at the library. It might be a connection issue.
Okay. All right, cool. Hopefully that will go away. All right, I'm going to go back to Stellarium now. So someone mentioned that they saw Orion, and that is correct. You can spot him by looking for his belt, which is 3 stars right in a row. They're pretty bright, and they make a straight line in the sky. So if you're looking at these stars right here, you found him. We can zoom in and get a closer look. Once you found his belt, you can find his shoulders and legs. So if we come up here, he's got 1 shoulder, there's another shoulder, there are 2 legs, and then a very teeny tiny head up here. And this is actually one of my favorite constellations. It's a wintertime constellation, so you can only see it for about half of the year, but it's really awesome when it's visible because it has a whole bunch of stuff going on inside of it. So first of all, you might have noticed that there's this smudge here that almost looks like a group of stars, but if we zoom in, we'll get a better look at what this actually is. So this is a giant cloud of gas and dust called a nebula that is dozens of light years across. By the way, a light year is the distance that light travels in 1 year, and it's roughly 6 trillion miles. So when we are measuring distances to other stars, you know, anything outside the solar system, it makes a lot more sense to use the light year as a unit, just because using miles or kilometers gets so crazy large that it really just doesn't make sense to use that unit anymore. And if you wanted to travel a light year, for example, at current technologies, like send a spacecraft a light year away or something like that, it would take tens of thousands of years to do that. So just to kind of give you some perspective on like the size of some of the things that we're looking at and how far away they are. So this is the Orion Nebula, and this giant cloud of gas and dust is an area where stars form. There are all different types of nebulas in the universe. Some of them result from stars running out of fuel and exploding, or just stars kind of dimming as they run out of fuel. And then there are some where stars actually form. So this is one of my favorites. And then a couple of my favorite stars are in Orion as well. Like this really bright, this bright red star here is called Beetlejuice. And that's a red supergiant. So it's an incredibly massive star nearing the end of its life. So really, really massive stars, when they start to run out of fuel, they will collapse in on themselves and then explode outward in a supernova. But that's only for really big stars. Smaller stars or average sized stars just kind of puff up and shed layers out. So not all stars explode.
That one does supernova. Will Earth feel it?
Ooh, that's a really good question. So Betelgeuse, this star, and then now you can see Orion. This star is, you can see right over here, is almost 500 light years away. So we won't actually experience anything on the surface of the Earth, but what would happen is that astronauts on the International Space Station or in orbit around the Earth would have to come back down to the surface, because a supernova emits a lot of radiation, and that radiation, even from 500 light years away, is very powerful, and that could endanger any astronauts in orbit around the Earth. So luckily, we're protected on the surface of the Earth. We have our atmosphere, we have a magnetic field that protects us, but astronauts are a little more vulnerable to that. So it wouldn't really have a big effect, but astronauts would have to be careful. All right. The other star in Orion I wanted to point out quickly was this one right down here called Rigel. It's a blue star, so stars come in different colors. Blue stars are much hotter than red stars, despite what our sink faucets say. They're very energetic. You can kind of think of a blue flame versus a red flame. The blue one's much, much hotter. So these are two of my personal favorite stars. If anyone is wondering what is this giant bright thing over here, this is actually the moon. The constellation that just came up is Gemini, so this is where the moon is located right now. And if we zoom in, you can actually see it in a little more detail.
I studied Gemini in my school once.
Oh, that's great. That's pretty cool. There's some really awesome stories that go behind a lot of these constellations. So I'm sure there are plenty about
I am
Gemini.
heavily educated in Greek and Roman mythology.
Please remember to keep your microphones muted, my friends, and type your questions in the chat so we're not interrupting the program.
I'll pause for questions in just a little bit when we transfer over to the other software. So I just wanted to give you an up-close view of the moon. And then there are 3 planets, that you can see. We got to move over to the southwestern part of the sky. And right up here, you'll see a really bright red object. This is Mars, also known as the red planet. So you can see that, and it actually appears very red in the sky. So if you're looking up over in the southwestern part of the sky and you see a really bright object that looks red, that is Mars. The other 2 planets have actually set already by this time. So I'm gonna go backward in time really quickly just to show you where you can spot them before they set for the night. So I think we got to go to about, yeah, this is fine. Very, very low on the horizon in the southwest. There are 2 planets. This one right here is the planet Jupiter. And we also have the planet Saturn. And we can zoom in on those as well. Get a better view there. But I want to show them to you in the other software. So I will zoom away now. All right, so that was my very abbreviated tour of the nighttime sky. I hope you saw some things that you found familiar, or maybe you learned something new. But now let's transition over to Worldwide Telescope. All right. So now everybody should be looking at the Earth, and I'm going to pause and check and see if there are any questions. All right. When is Beetlejuice going to go supernova? That's a good question. It's hard to say for sure, but astronomers say soon. And when we say soon, when astronomers in general say soon, they mean within like 100,000 years or so, because that's pretty soon over the course of a star's lifetime. So it does, Betelgeuse itself is a variable star, so it tends to get brighter and dimmer periodically, which is totally normal. This past year, it got a lot dimmer than it normally does, which kind of sparked some interest, and some folks were suspecting that maybe it would go supernova, but it turns out that there was just a giant cloud of dust that went in front of Betelgeuse. Or that was part of the reason that it dimmed so much. So it's probably not going to go supernova in any of our lifetimes, but in the grand scheme of things, soon-ish. All right. Okay, let's go into Worldwide Telescope. And I pointed out Mars, Jupiter, and Saturn. So I thought it would be fun if we went to visit one of those planets. So if you want to type in your preference into the chat, please do. If none of those planets are the one that you want to go to, you can type in whatever planet you want. But whichever one I see the most of will be the one that we visit. And if we have time, maybe we could go to 2. Right, let's see. Ooh, I'm seeing a lot of Saturns. That's always a favorite. A Pluto, of course, a couple Plutos. Not a planet, but we'll talk about it, don't worry. All right, it looks like Venus is getting some love too. It looks like people want to go to Saturn. All right, so let's stop there first, and then if we have time, we can go to one of those other planets as well. So we're going to zoom out. This is called Worldwide Telescope, and this software allows you to view the nighttime sky similar to Stellarium. It's just, in my personal opinion, not quite as good at it. I like this program or this software specifically because it allows you to fly around. You can actually see Orion right over here. But we're going to head to Saturn. And I'll get rid of that so that we get a better view. All right, so normally if you were going to send a spacecraft out to Saturn, it would take a very long time because Saturn is about 1 billion miles away from the sun. The Earth is roughly 93 million miles away from the sun. So Saturn is a lot farther out. It's nearly double the distance as Jupiter is from the sun. So once you get to these gas planets in the outer solar system, the distances tend to double. So Jupiter is the one right after all the rocky planets, and then you have Saturn, which is double that distance, Uranus, which is double Saturn's distance, and Neptune, which is double Uranus's distance. So the distances get huge. And just to go over all the planets actually really quickly, we've got Mercury, which is the closest to the sun. Then we have Venus, Earth comes after that, Mars, Jupiter, Saturn, Uranus, Neptune. And then the 4 inner planets are made of rock, or mostly rock, and the 4 outer planets are the gas giants, so they're made of gas. Saturn and Jupiter, actually all of them are mostly hydrogen and helium gases, but you'll notice that they do have different colors. Saturn has different colors on its surface, or I should really say the top of its atmosphere. And this yellowish hue is actually because of a gas called ammonia in the atmosphere. So it gives it a little yellow, which is pretty cool. You'll notice that there are a lot of swirls on the surface of Saturn and bands. So the bands and storms and swirls happen because Saturn is incredibly massive and it's spinning pretty quickly. So if you could open up Saturn like a cookie jar and try to fill it with Earths, you could fit over 750 Earths inside of Saturn. So really, really big. And it's also, it's very big in size, and it's also very massive. So there's a difference between size and mass. Size is a measurement of how much space something takes up, whereas mass is a measurement of how much stuff something is made up of. So Saturn is both very large and very massive. Now it also spins very quickly. So Saturn's day is only about 10 hours compared to Earth's day. That's pretty quick. So when you take all of that material and you start spinning it really quickly, you get a lot of storms, you get a lot of bands in the upper regions of the atmosphere. If we look at the pole of Saturn, you'll notice this really weird kind of hexagonal pattern that is a storm, and each side of the hexagonal pattern is like a jet stream. So you can think about the jet stream here on Earth. It's similar on Saturn, just a lot more powerful. And then, of course, the coolest thing about Saturn, in my opinion, is probably the rings. The rings are incredible, and you can see them with a backyard telescope, sometimes even a very, very strong pair of binoculars. You might be able to see the rings of Saturn. Now, the rings are not solid all the way around. They are made up of chunks of ice. So some of these chunks are as small as your hand. Some of them are as big as a whole cruise ship. But we think that a moon, an icy moon, got a little bit too close to Saturn at some point in the past. And Saturn's gravity, because it is so massive, tore it apart into lots and lots of pieces of ice. And so that's what eventually settled into Saturn's current ring system. We think it is left over from an icy moon. Now, you might have noticed there are some gaps in the rings as well. There's one gap in particular that is larger than the others. The gaps are caused by moons. So Saturn has a lot of moons. I'll get to those in a minute. But some of the closer ones, their gravity interacts with Saturn and actually causes a separation in the rings. So this really big gap here is caused by a moon called M.A.Z.E, which actually kind of looks like the Death Star. So if you like Star Wars and you like space, which I feel like you kind of have to like both of them, you should look up a picture of M.A.Z.E, the moon, because it does kind of look like the Death Star. But I assure you there are no planet-destroying lasers on the moon of M.A.Z.E. But its gravity is what is causing this giant gap in the ring system. Now, speaking of moons, Saturn, as I mentioned, is very massive and has a lot of gravity, so it is able to hang on to a lot of moons. And I believe I can turn on let's see if I can turn on their orbit lines. Maybe not. All right, well, Saturn has 82 moons, last count. Let's see. There we go. All right, now there's a bunch of lines all over the place. So these are all of Saturn's moons. You can see that some that are orbiting closer to the planet itself are all kind of nice and neat and in line with Saturn. Those moons probably formed when Saturn formed. So it was just extra material that clumped together, coalesced into these moons. And then as we get farther out, you'll see that the moon orbits get kind of crazy. They're all crisscrossing. They're all really tilted compared to the inner moons, and some of them are even orbiting backward. So a lot of these moons are thought to be captured moons. So an object like an asteroid, was floating by, maybe got flung out of the asteroid belt, and it was passing Saturn, and Saturn's gravity kind of snatched it up, and it got stuck in orbit around Saturn. So a lot of these weird ones are probably captured. But it's pretty cool because astronomers find new moons all the time. Like Saturn, just about a year ago, had 62 moons. So astronomers discovered 20 new moons in just the last year orbiting around Saturn. And a similar thing happened to Jupiter. So we're finding new stuff all the time, which is pretty cool. One of my favorite moons is actually in orbit around Saturn. It's called Enceladus, and it's got an entire surface of ice, water ice specifically, but underneath the surface there is a liquid water ocean. And this was discovered from the spacecraft called Cassini. And this is just a really surprising discovery because it's so cold all the way out here in the outer solar system that astronomers never thought that there could be any kind of liquid water, but they were really referring to liquid water on the surface. If you go underneath the surface of some of these moons, it's much warmer because of gravitational interactions with the planet itself. So in this case, Saturn, Jupiter has a few. Jupiter is very massive as well. So under the surface, it's actually warm enough to have a liquid water ocean. So I think that a lot of these outer icy moons are really interesting places to send more spacecraft. We should definitely investigate them further. All right, I will pause and see if there are any questions. Do the moons collide on the crazy paths? That is a really good question. For the most part, no, because even though it looks like they cross paths, they're not always crossing paths at the exact same point. So it doesn't really happen very often at this point in the whole solar system's history and present day. But earlier in the solar system, so we'll say like 3 to 4 billion years ago, the solar system was a lot more chaotic. So there were a lot of objects kind of flying around. Nothing had necessarily coalesced completely yet. So it's very possible that back in that time, objects collided a lot more frequently than they do now. All right, do moons of Saturn travel along an ellipse? Yes, they do. So anything that has that is orbiting another object, for the most part, is an ellipse. There are some orbits that are very close to being circular. So actually, if we zoom out, I can show you. So if we look from kind of a top-down view here, you'll see that most of the planets are actually almost perfect circles. They're not technically perfect circles, so they are ellipses, but any kind of object orbiting another one is going to have some kind of elliptical orbit. Technically, a circular orbit is still an ellipse, but an ellipse is not always a circle. It's kind of the square and rectangle thing there. But yes, you are correct. So all moons orbiting planets orbit in ellipses. Stars orbiting other stars orbit in ellipses too, which can happen. It's a good question. How are we discovering so many moons each year? More accurate telescopes. That's a good question as well. So a lot of what we have discovered, especially with Uranus and Neptune, the outermost gas planets, are discovered using telescopes from here on Earth. But with Jupiter and Saturn, a lot of them have been discovered using telescopes from the Earth, but we've also been able to send spacecraft out to orbit around Jupiter and Saturn, which we haven't done with Uranus or Neptune. Not because we can't, but it's just not really on the list of places to go. So Jupiter and Saturn have had spacecraft that have orbited around them. So they've gotten a much more up close look at the areas around those planets and have studied them for many, many years. So Jupiter and Saturn have a lot more moons discovered around them, partially because they're so massive, but also because we're able to study them a lot better than we can study Uranus or Neptune. All right, how are planets made? Yeah, so planets start in what's called a protoplanetary disk. So if you think back to when we were looking at the Orion Nebula, that was a huge cloud of gas and dust. And that's an area where stars form. So pockets of that cloud of gas and dust will sometimes clump together. You can kind of think of it like a dust bunny or a snowball, where it gets bigger and bigger over time. In the case of a new star, it's because if a bunch of material is clumped together, it also has a lot of gravity because it's a very massive clump. So it attracts more and more material over time. And eventually that material will collapse in on itself, and pressures and temperatures rise in the core of that clump. And that's how a star ignites. That's how a star forms. It's a process called nuclear fusion that happens at these really high pressures and temperatures. But the star doesn't use up all of that material necessarily. A lot of that material is still spinning around the star. And so that material can then clump together and form smaller objects that don't undergo nuclear fusion. And that's where we get planets. So a lot of the times rocky material will clump together and form rocky planets. And a lot of the times gaseous material will clump together to form gas planets. So it's all kind of this rotating, lots of angular momentum is involved, lots of gas and dust, and just material clumping together like a dust bunny or a snowball. All right, so I think at this point, I want to leave our solar system behind and explore a little bit farther out. So we'll take a look at our whole galaxy. If you're wondering what this white orbit line out here is, that is the orbit of Pluto. I did actually mention that I would talk about this, so I'll briefly talk about Pluto, but it's not considered a planet. It was changed back in 2006, and it hasn't been considered a planet since. So we have 8 planets, and then we have dwarf planets, and Pluto is considered a dwarf planet, and there's a few others out here as well. There's 5 dwarf planets in total. But the reason that Pluto is not a planet anymore is because we started to learn more about the solar system. So at one point in our history, there were 16 planets in the early 1800s. And that's because astronomers were observing Let me center on the sun actually instead of Saturn. That way we can get a better view. So in between Mars and Jupiter, the kind of separating area between the inner solar system and the outer solar system, there's an asteroid belt, right? That's what we know of as being there today. And I can turn those on as well. So you can see all the asteroids. All right, there we go. And we'll move away from the sun. So right in between Mars and Jupiter, you can see this red area full of asteroids. So astronomers were looking in this part of the solar system, and this was before they had discovered the asteroid belt. And they were finding a lot of objects and calling them planets. So at one point, even before the discovery of Neptune, we had 16 planets in our solar system because of these objects in between Mars and Jupiter. But then astronomers started to find a whole bunch more. And so then they realized that maybe what they're discovering, they're not planets, but they're a different classification of objects, because these objects are all really small and mostly rock and metal, and they're not spherical. They're shaped more like lumpy potatoes. And so that's when they came up with the asteroid belt as a classification for these objects. And basically the same thing happened with Pluto. So in the late 1990s and early 2000s, astronomers started discovering a whole classification or a whole group of objects out orbiting with Pluto. Pluto happens to be the biggest one of these objects, but they're all very similar to Pluto. So Pluto itself is very small. It's only about the size of half of the United States if you were to compare its diameter to distance on Earth. And it's made of ice and rock mostly. So it doesn't necessarily look like a gas planet, which is what you might expect being really far away in the outer solar system. But none of those characteristics made Pluto not a planet. It's because of all of these other objects that look and act just like Pluto. They've got weird orbits that are out of line. They're all very small and icy. And so astronomers thought it made a lot more sense to start calling Pluto a Kuiper belt object than it did a planet. So this whole area out here is called the Kuiper belt, and it's made up of hundreds of thousands of these icy bodies, and Pluto is one of them. And then, as I mentioned, it also has the designation of a dwarf planet. A dwarf planet is any planet, or excuse me, a dwarf planet is any object that is big enough to be round and that orbits the sun. So you have to be a certain size in order to be round, because you need enough mass in order for gravity to pull you into a round shape. So a lot of these smaller objects are shaped like lumpy potatoes because they don't have enough mass to be round. So dwarf planets are kind of like the in-between for, planets and asteroids or Kuiper belt objects. And so Pluto is considered one of them. All right, let's head out into interstellar space. So as I mentioned earlier, if you're traveling many light years at current technologies, just getting to the nearest star, which is 4 light years away, would take almost 100,000 years to actually travel there. So all that we know from other stars, other galaxies, is from telescopes. Telescopes have taught us so much about the universe, and it's all because we are looking at the light from these objects. So we're going to keep going out. That's our solar system, but we are just a very, very small part of our galaxy. So the solar system is just the sun and the 8 planets and the asteroid belt and the Kuiper belt. There's some other stuff thrown in there too.
Isn't there a black hole?
The black hole, yes. I will get to the black hole in just a minute because that's a really, really awesome thing about our galaxy. So we have our solar system. It's kind of like our little neighborhood. And then there are other stars in our galaxy, and those are like solar systems. And then our galaxy is like, the entire continent of North America, for example, and each solar system is like a town or a neighborhood. And so in our whole galaxy, which hopefully you can see right now because it is taxing on the computer sometimes, so I want to make sure. I'm going to close out of Stellarium. All right, there we go. So this is our galaxy, and we call it the Milky Way. And there are roughly 300 billion stars in our galaxy alone. And you can see where the crosshair is right in the center. That's where the sun and our solar system is located within the galaxy. From all the way out here, the sun is microscopic. You can't see it. All of the stars that make up the constellations are also around these crosshairs. So when we look up at the sky at night, we're actually seeing like a very small amount of our galaxy. But if you're wondering, how do we know what our galaxy looks like? Because getting all the way out here, sending a spacecraft out here would take, you know, hundreds of millions of years. So what we do is astronomers observe the motions of objects within our galaxy. So how stars move over long periods of time. They can look into the central regions of the galaxy as well. And they can also observe other galaxies that we're not a part of. So we have a good model of what the Milky Way looks like. We live in a barred spiral galaxy. The barred comes from this almost football shaped like part in the center. And then the spiral comes from these spiral arms, the beautiful spiral arms. And if you're wondering what is at the center, because it looks like a giant ball of light, well, there are around 10 million stars all clustered together at the center of our galaxy. And at the center of that cluster is a supermassive black hole. Now that sounds scary, but it's not, I promise, because the center of the galaxy is 26,000 light years away from our solar system. So we are very far away. And the supermassive black hole is actually really important to keep our galaxy together. A lot of these central objects and the central stars in our galaxy are orbiting around that supermassive black hole. So it's very important that we have it. To the formation of the galaxy may not have ever happened in the first place without the black hole, but also it's responsible for keeping a lot of the galaxy together. So yeah, that's the center of the galaxy. Black holes don't suck things up. Things can fall into black holes if they get too close. So, you know, if a star is moving slowly and it's too close to a black hole, it can fall in, but it's not going to like suck up everything around it. That's kind of a science fiction representation of what a black hole is. But they form when really, really massive stars go supernova, as we talked about earlier in the show. But the cores of that star continues to collapse in on itself. And if it collapses all the way, it will collapse into an infinitely small space. And that's how a black hole actually forms. So we have black holes that have the same mass as a star. It's just all confined to a really, really small space. And then we also have supermassive black holes, which have probably eaten up a lot of material over time. A lot of stuff has fallen into these really, really, really massive ones to make them so big. And that's how we think that the Milky Way's black hole got so big. It's possible that it may have also collided with other black holes, because we are not the only galaxy. We have a neighborhood of galaxies. The Andromeda Galaxy is our nearest neighbor, and we're on a collision course with Andromeda, but don't worry, that won't happen for 4 billion years or so. But when that does
what about Alpha Centauri?
Alpha Centauri is inside of our galaxy. So that's the nearest star system. So that's like pretty much right near the crosshair here. So you can't actually see it from this distance because it's inside of the Milky Way. Right now we're outside the Milky Way, and we're gonna get even farther and look at all of the galaxies that we have observed. So hopefully, there we go. We have basically made it to the edge of the visible universe. All of these points of light are galaxies. with, anywhere from millions to trillions of stars. Astronomers estimate that there are the same number of planets as stars in the universe. So for every star, you can check off a planet. And this is everything that we've observed with telescopes. So I think, getting to the edge of the visible universe on a Thursday night isn't too bad. So I'll leave us out here and I can take any more questions. I've talked enough. I think we can take questions now. Are Andromeda and the Milky Way the biggest galaxies in our cluster? Yeah, so the Milky Way and Andromeda are two galaxies in the local group. The local group is basically our neighborhood of galaxies. There are about 54 of them. And Andromeda is the largest at about 1 trillion stars, and Milky Way is the second largest with about 300 billion. Let's see, let me backtrack a bit. Let's see. Is Jupiter a brown dwarf, and what is a brown dwarf? So a brown dwarf is, it's kind of like a mix between a planet and a star. Jupiter is not a brown dwarf. It's not big enough, but it's basically a name for an object that's right on the threshold between starting nuclear fusion, because it's really massive, but also not quite powerful enough to become a full-blown star fueling itself. So it's kind of like this weird in-between object. But no, Jupiter is not massive enough to be a brown dwarf. How are asteroids made? So asteroids are just, bits of rock and metal that have, clumped together after a star forms. So it's pretty much the same process as how a planet forms, just not on as big of a scale. Asteroids are a lot smaller than planets. What does an astrophysicist do? That's a really good question. So an astrophysicist studies the physics of the universe in a space context. So astronomers tend to focus more on observation or studying like planetary astronomers that are studying planetary science. But astrophysicists, a lot of them tend to study the dynamics of the universe and how the universe changes over time. So they'll work on a lot of, like the expansion of the universe, for example, and figuring out how fast it's expanding and things like that is what an astrophysicist does. All right, the planetarium is open. Yes, we don't have live shows, unfortunately, but we do have like movie-like shows, and our schedule is on our website. Where is Voyager on the map? All right, let's go back in. Let's see how fast we can get back in. And we'll see. We're going right back into the galaxy. And we got to get really close to the solar system, because even though it's the farthest spacecraft that humans have ever sent out into space, it's actually still pretty close by in the grand scheme of things. Ooh, okay, so if we're looking at the solar system, and let me just check and see if there's a way to put it on. It doesn't look like it. All right, so if the Voyager spacecraft, there's two Voyagers, Voyager 1 and Voyager 2. Voyager 1 is farther than Voyager 2. It was launched in 1977, and it's been traveling ever since. We are still in communication with the spacecraft. It's no longer doing its mission because it, finished that a long time ago, but it is the farthest thing out in space. So if the Earth is somewhere in here, Voyager 1 is like right around here. So it's in light hours. It is roughly 20 light hours away, which means it takes light 20 hours to reach Voyager, or for Voyager to reach us, just light. So in real time, it's traveled about 40 years, and it's traveling at about 10 miles per second. So it's going pretty fast. And if it wanted to go to the nearest star system, Alpha Centauri, which is 4 light years away, it would take about 70,000 years to get there if it was headed in that direction, but it's not. All right, which planet can you see the most with the naked eye? So you can see all of the planets with the naked eye out to Saturn. The planet that is the brightest or appears the brightest when it's visible is Venus, because Venus is, relatively close to the Earth, and it also has a very thick atmosphere, so it reflects a lot of sunlight. So it appears very bright to us in our sky. All right, what planet has the most moons? That would be Saturn with 82 moons. Which galaxy has the most planets? We don't know. We don't even know how many planets our own galaxy has. There is an estimation that there are the same number of planets as stars in the universe. So if you're going off of that, Andromeda, at least in our local neighborhood, would have the most planets because it has 1 trillion stars. As for other galaxies out there, I am not sure. All right, so I'll take these last two questions here, and then maybe we'll wrap things up. So what's on the dark side of the moon? So the other side of the moon, and I can show you this in Worldwide Telescope. Let's see, we're going to the moon. So first off, I just want to clarify that the dark side of the moon isn't actually dark. It's just the side that we don't see from here on Earth. Let me turn off these asteroids. Okay. So this is the side of the moon that is facing the Earth. The moon is tidally locked with the Earth, meaning that the same side always faces the Earth. So we're always seeing that side. But let me actually bump up their sizes. You might be able to see it a bit better. All right, so there we go. So we're always seeing the same side, but the other side, which actually it's a half moon right now. I think this is third quarter. So we're actually only seeing a part of the side that is facing the Earth. So right, this is more like what we see from the Earth. But the other side of the moon actually gets just as much sunlight as the side that faces the Earth. So it's never actually dark. But the other side of the moon actually just has a whole bunch of craters. We've been able to send spacecraft to take pictures of the other side of the moon, and there aren't as many of these dark spots. These are called the lunar maria. And it's basically just basins of basalt, so dried lava beds from really early on in the solar system when the moon was more molten rock. It is now dried, and there's no volcanoes on it anymore, active volcanoes anymore, but that's a result of the volcanoes. But the other side doesn't really have much of that, and it's covered in craters for the most part, impact craters. So it's not dark, it's just a little different. All right, and the last question, did they found 12 ounces of water on the moon? I'm not actually sure about that one. I know there was a recent discovery of there being more water than they thought on the moon. There's always been water on the moon. It's just been in its ice form, especially at the kind of polar regions. There are these caves that never get any sunlight, and so there's a lot of frozen water in there. There's a lot of frozen water in the soil as well. And there was a recent kind of news story that came out about water on the moon, but honestly, I am ashamed to say that I don't know too much about it. So I'll have to look that one up at a later point. All right, so I will go back to full me. Thank you all so much for joining us today. I hope that you learned a lot, and I hope that I answered as many questions as I could. So I will turn it back to you, Kat. Oh, and then let me show you, these are the two links. So Worldwide Telescope is worldwidetelescope.org/download. Unfortunately, it's only available for Windows, but it is free still, and then Stellarium.org. So I'll leave this up. Thank you.
Oh, thank you so much for joining us. That was so interesting. I really appreciate you taking the time to join us tonight, and thank you everybody for coming in. I'm going to